Good morning, everyone. Myself Devika, working as Assistant Professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today we have learned the subject on MOR 3452 Control Systems Engineering for 2021 regulations. Now we are going to discuss the topic state space analysis. It explains the basics of state space analysis in control systems engineering. It introduces modern control techniques used for analyzing dynamic systems. So traditional benefits of the state space model. So in traditional transfer function method versus state variable methods. So the traditional transfer function method is mainly used for simple linear systems. So the state variable method is more advanced and it can handle non-linear, time varying and multiple multi-input, multi-output systems. So it is also capable of handling arbitrary input signals and it accounts for all initial conditions. Benefits of a state space method. So state space analysis provides complete information about the internal behavior of a system. It considers all initial conditions and works effectively for a complex systems. So classical method for transfer functions. So it converts differential equations into transfer functions using Laplace transforms. So it is also useful for stability and transient response analysis of linear time invariant systems. So contemporary framework for state space method. So it is a modern approach for modeling and controlling systems, and it is also suitable for non-linear and time varying systems, and it is widely supported by the software tools. Contemporary methodology for state space analysis. So it can represent complex practical systems like aircraft and missiles. So although powerful, it requires more mathematical computations than classical methods. State space representations. In state space representation, system equations are written as first order differential equations. So using initial conditions and inputs, the future behavior of the system can be also predicted. Understanding state variables. So the state variables are the minimum set of variables needed to describe a system completely. So the collection of these variables forms the state vector and defines the state space. So this is the block diagram of a state space system. It shows the block diagram representation of a continuous time control system using state variables. It also explains the relationship between input, state and output. Time varying and time invariant systems. So systems can be time varying or time invariant depending on whether system parameters change with time. So the state space equations can represent both types effectively. State and output equations. So the matrices A, B, C and D define the system dynamics, input, output and direct transmission. So these equations form the mathematical model of control systems. So the general equations of general state space equations. So the equations x dot is equal to ax plus bu and output equation y equal to cx plus du. It represent the standard state space model. So they describe how the system and output depend on the system and input matrices. Understanding the RLC circuits. It explains how an RLC circuit can be modeled using state space analysis. So the voltage and current are selected as state variables to derive the system equations. Thank you.